10 years later, in 1881, one of the most famous experiments ever performed was about to add even more controversy to the heliocentric-geocentric debate. Albert Michelson, a world-class physicist, had invented the interferometer, a machine designed to measure the interference patterns of two light beams moving against each other. Its principle was similar to Fizeau's experiment, but it was much more sensitive. Instead of sending the light beams in parallel paths through water, Michelson sent them in numerous perpendicular paths through air on a rotating table, which would allow a more comprehensive and accurate test. Michelson directed one of the light beams toward the west, since this is, as everyone believed, the direction of the Earth's movement around the Sun. This would automatically point the other beam toward the North Pole. Hence, the light beam going west would head right into the ether at the supposed speed of the Earth around the Sun at 66,000 miles per hour, while the light beam going north would experience very little or no ether resistance. When the light beams returned to the receiving plate, Michelson assumed, based on the then reigning Fresnel drag theory of ether, that the westbound light beam would travel slower and come back later than the northbound light beam, due to the pressure from the ether on the westbound beam. If we picture the light beams as particles, then if the westbound beam was slower, the particles of the two light beams would not coincide when they finished their respective routes in Michelson's interferometer. The north particle would be ahead of the west particle by a wide enough margin that the difference would mean the Earth was revolving around the Sun. Thus, Michelson expected the north particle and the west particle to be separated by a wide margin. If we assume the light beams are waves, then, if the Earth were revolving around the Sun, Michelson expected the waves to be separated by a wide margin.
But to his astonishment, Michelson saw only a minuscule of separation between the waves. The wave peaks and troves were very close together. Under the physics of that day, Michelson's results strongly suggested the Earth wasn't moving. Hence, what Arago and Airy found examining starlight was now confirmed by Michelson with terrestrial light. By all experimental indications, the Earth was standing still in space, and modern science was confronted with its most astounding yet devastating evidence that had the potential to destroy its very foundation: the Copernican principle.
Michelson reported these findings in the American Journal of Science in 1881, stating, quote,
"This conclusion directly contradicts the explanation, which presupposes that the Earth moves."
After some consultation with Hendrik Lorentz and Lord Kelvin, Michelson decided to make a more sensitive interferometer and take extreme precautions against any outside disturbances that may have affected his first experiment. Alexander Graham Bell funded the new project, and Michelson took on a partner by the name of Edward Morley. The experiment was performed in 1887. But the results of this second experiment were even worse than the first experiment for the heliocentrists. Michelson saw a mere small fraction of what he should have seen if indeed the Earth was revolving around the Sun. Michelson himself said,
"The actual displacement was certainly less than the 20th part of this, and probably less than the 40th part. But since the displacement is proportional to the square of the velocity, the relative velocity of the Earth in the ether is probably less than 1/6 the Earth's orbital velocity, and certainly less than 1/4.
The predicted results were meticulously calculated based on the undisputed facts on the behavior of light waves. Thus, no one could fault the procedure used by Michelson. In fact, it was the renowned physicist James Clerk Maxwell, world famous for his electromagnetic equations of light travel which are still used today, who proposed the idea of using the interference of light waves to determine if the Earth was moving. Once the failure of the Michelson-Morley experiment to prove the Earth is revolving around the Sun was released, the whole scientific community was in consternation. The top physicists in the world were contacted to offer an explanation for this astounding result. One of them was the Dutch physicist Hendrik Lorentz. A January 7, 1891 correspondence between Lorentz and Michelson reveals that Lorentz had communicated with Michelson and had studied both his 1881 and 1887 experiments. Michelson writes,
My dear Professor Lorentz, I am sorry I cannot give more satisfactory replies to your questions. But perhaps you will make proper allowances when you know that while the American Association honored me by calling on me to preside over the physical section, this, as well as all other appointments of the important aims of the association, I forward with this a copy of the proceedings for 1881, and I hope you may be able to form from it a better estimate than by my imperfect description. With great respect, I remain your servant. Signed, Albert A. Michelson.
Michelson couldn't offer Lorentz much help in explaining the Michelson-Morley experiment, for he was just as confounded as everyone else. A year after the correspondence with Michelson, Lorentz wrote to English physicist Lord Rayleigh on August 8, 1892, expressing his exasperation over Michelson's experiment. He writes,
I have read this note with much interest, and I gather from it that you agree completely as to the position of the case. Fresnel's hypothesis, taken conjointly with his coefficient 1 minus 1 over n squared, would serve admirably to account for all the observed phenomena, were it not for the interferential experiment of Mr. Michelson, which has, as you know, been repeated after I published some remarks on its original form, and which seems decidedly to contradict Fresnel's view. I'm totally at a loss how to solve the contradiction, and yet I believe that if Fresnel's wave theory is abandoned, we should have no adequate aberration theory at all for the conditions imposed by Mr. Stokes on the movement of the ether being irreconcilable to each other. Can there be some point in the theory of Mr. Michelson's experiment which has yet been overseen? In the meantime, I have endeavored to apply the electromagnetic theory to a body which moves through the ether without dragging this medium along with it. Signed, H.A. Lorentz.
We see that although Fresnel's ether drag theory was used to explain why Arago could not detect the Earth moving, Lorentz admits that Fresnel's theory cannot be used to explain the Michelson-Morley experiment, for it simply gives too large of a result. But Lorentz is fearful of relinquishing Fresnel's theory, since then he will no longer be able to use it to explain either Arago's experiment or stellar aberration. Desperate for an answer, Lorentz asks if somehow Michelson made a mistake in his experiment. Prior to getting an answer from Rayleigh, Lorentz says that he has temporarily posited a new theory to explain it, which we will see momentarily. For now, it is worthwhile for us to know that when scientists and historians of the following decades looked back on the Michelson-Morley experiment, they too realized that it came as close to confirming the medieval worldview of a motionless Earth as any experiment that modern times had to offer. In 1901, Henry Poincaré stated in his book Science and Hypotheses, quote,
A great deal of research has been carried out concerning the influence of the Earth's movement. The results were always negative.
In 1905, commenting on what he called the indubitable results of the experiment of Michelson, Poincaré then stated in the magazine The Monist, quote,
Are we about to enter now upon the eve of a second crisis? These principles on which we have built all, are they about to crumble away in their turn?
In 1958, referring to the, quote, negative results of Michelson's interferometer experiment, unquote, and the dozens of other similar experiments performed through the 1930s that yielded the same results as Michelson's, the famous physicist Wolfgang Pauli admitted to what he called, quote,
the failure of the many attempts to measure terrestrially any effects of the Earth's motion.
In the late 1950s, historian Bernard Jaffe stated in his book, Michelson and the Speed of Light, quote,
"The data were almost unbelievable. There was only one other possible conclusion to draw, that the Earth was at rest."
Science historian and physicist John D. Bernal stated in his book, Science and History, quote,
"The Michelson-Morley experiment was the greatest negative result in the history of science."
In the late 1960s, historian Adolf Baker in his book, Modern Physics and Antiphysics, stated, quote,
Thus, failure to observe different speeds of light at different times of the year suggested that the Earth must be at rest in the ether. It was therefore the preferred frame for measuring absolute motion in space.
In 1954, theoretical physicist James Coleman wrote in his book, Relativity for the Layman, the following admission.
The easiest explanation was that the Earth was fixed in the ether and that everything else in the universe moved with respect to the Earth and the ether. Such an idea was not considered seriously, since it would mean in effect that our Earth occupied the omnipotent position in the universe, with all the other heavenly bodies paying homage by moving around it.
In 1949, physicist G.J. Whitrow realized the tremendous impact of the Michelson-Morley experiment in light of the Catholic Church's debate with Galileo, and admitted the following, quote,
It is both amusing and instructive to speculate on what might have happened if such an experiment could have been performed in the 16th or 17th centuries, when men were debating the rival merits of the Copernican and Ptolemaic systems. The result would surely have been interpreted as conclusive evidence for the immobility of the Earth, and therefore as a triumphant vindication of the Ptolemaic system and irrefutable falsification of the Copernican hypothesis.
Needless to say, modern science was, shall we say, bent on eliminating the idea that our tiny Earth occupied the omnipotent position in the universe. The theological, philosophical, cultural, and political ramifications of such a reversal in the dogma and the power of science were unacceptable for modern man.
To help modern man get out of this dilemma, two of the leading physicists of the day, George Fitzgerald and Henrik Lorentz, came up with a creative solution to explain Michelson's astounding results. Although, as we have seen in Lorentz's 1892 letter to Lord Raleigh, Lorentz revealed he was struggling with how to explain Michelson's experiment. 2 years later, in 1894, he developed a solution he had hinted at in his 1892 letter. As we will recall, in his 1892 letter, Lorentz stated,
Can there be some point in the theory of Mr. Michelson's experiment which has yet been overseen? In the meantime, I've endeavored to apply the electromagnetic theory to a body which moves through the ether without dragging the medium along with it. Signed, H.A. Lorentz.
Here we see that Lorentz was theorizing that a material body somehow changes as it travels through space and against the ether. He shared this new theory in a letter to George Fitzgerald, a physicist from Ireland. The letter of November 10, 1894, of which this is the original, states,
My dear sir, in his aberration problems, Professor Oliver Lodge mentions a hypothesis which you have imagined in order to account for the negative results of Mr. Michelson's experiment. 2 years ago, I arrived at the same view, as you may see from the number of the proceedings of the Dutch Academy of Sciences, which I have the honor to send you at the same time with this letter. A memoir in which I consider the whole subject of aberration in connection with the electromagnetic theory of light being now in course of publication. It will in fact appear in a week. You would oblige me very much by telling me if your hypothesis has already been published. I have been unable to find it, and yet I should wish to refer to it. Most respectfully yours, H.A. Lorentz.
In a return letter dated 4 days later on November 14, 1894, Fitzgerald writes to Lorentz the following.
My dear sir, I have been for years preaching and lecturing on the doctrine that Michelson's experiment proves, and is one of the only ways of proving, that the length of a body depends on how it is moving through the ether. I am particularly delighted to hear that you agree with me, for I have been rather laughed at for my view over here. I could not even persuade my own pupil, W. Preston, to introduce this criticism into his book on light, published in 1890, although I pressed upon him to do so, and it was only after reiterated positiveness that I induced Dr. Lodge to mention it in his paper. But now that I have you as an advocate and authority, I shall begin to jeer at others for holding any other view. Signed, George Fitzgerald.
According to Lorentz's 1895 paper titled Attempt of a Theory of Electrical and Optical Phenomena in Moving Bodies, Lorentz admitted that, quote,
by Fresnel's theory, a displacement of 0.4 of the fringe distance was to be expected. Nevertheless, during the rotation, only displacements of at most 0.02 of the fringe distance were obtained.
As noted previously, the displacement of which Lorentz is referring is the distance between the peaks of the light waves. A long displacement of 0.4 would mean that the Earth was revolving around the Sun, but the displacement was only 0.02, which is only 5% of 0.40. Thus, the displacement was 95% less than what was expected if one were to use Fresnel's drag theory to explain why it appeared as if the Earth was not moving. This meant that Fresnel's equation was useless to heliocentrists in trying to explain the Michelson-Morley experiment. Obviously, another solution had to be sought. Stuck for an answer, Fitzgerald hypothesized that the west wave of Michelson's interferometer returned about the same time as the north wave because the ether through which the Earth was moving at 66,000 miles per hour put significant pressure on the westward arm of the interferometer and thereby shortened it just enough so that the two waves coincided upon their mutual return. Later, the shortening of the arm of the interferometer was dubbed the Fitzgerald contraction or the Lorentz-Fitzgerald contraction. As shown in the diagram, Lorentz's theory held that the electrons in the object were flattened when the object moved in space against the ether.
Many scientists were not pleased with the new contraction theory, since it seemed to be an ad hoc fix to replace the discredited Fresnel ether drag theory. But since no one had come forth with a better explanation to Michelson's experiment, Lorentz's hypothesis remained unchallenged. Science was in a bit of a quandary.
The American writer explains this quandary as follows in his biography of Albert Einstein.
In the United States, Albert Michelson and Edward Morley had performed an experiment which confronted scientists with an appalling choice. Designed to show the existence of the ether, it had yielded a null result, leaving science with the alternatives of tossing aside the key, which had helped explain the phenomena of electricity, magnetism, and light, or of deciding that the Earth was not, in fact, moving at all.
As we noted earlier, both Fitzgerald and Lorentz had hypothesized the contraction theory to answer Michelson's experiment, but Lorentz invented a mathematical equation to represent it. Next to Newton's famous F equals ma, Lorentz's equation would become the next most famous equation that science had ever produced. It became known as the Lorentz transform equation. This equation means that the new length of a moving object will be the old length that will be shortened by the Lorentz transform factor. Perhaps an easier way to understand this equation is to look at it as a ratio. The ratio will always be less than 1 to 1. In this case, it is the ratio of 1 to 1 minus the square root of the velocity of the object squared divided by the velocity of the speed of light squared. Since the product of the square root of a number less than 1 will always be less than 1, modifying the length of a moving object by using the Lorentz transform means that the new length will always be less than the original length. It also means that the faster the object moves, the shorter the new length will become. Essentially, to avoid the possibility of a motionless Earth as a viable solution to the Michelson-Morley experiment, Lorentz's equation was henceforth employed to transform, as it were, any such experiment that was designed to test whether the Earth was moving into a positive result. Despite the fact that all of the experiments performed in the 1800s had never shown evidence that the Earth moved, it was nevertheless held as an indisputable scientific dogma that the Earth revolved around the Sun. As such, any experimental results indicating that the Earth was not moving were transformed into a moving Earth by Lorentz's mathematical equation. It didn't matter that Lorentz's equation was based on an ad hoc theory that was never empirically demonstrated to be true. In fact, prior to Lorentz's and Fitzgerald's hypothesis, ether was understood as a perfect fluid that produced no pressure or friction against matter. Physicist Arthur Eddington, a contemporary of Michelson and Lorentz, later remarked in his 1929 book, The Nature of the Physical World, that there were only two alternatives for modern science after the Michelson-Morley experiment. Either they accept the fact that the Earth isn't moving, or they had to accept Fitzgerald's and Lorentz's hypothesis that the length of an object contracted when it moved. Perhaps unable to see himself as a geocentrist, Eddington did everything he could to make Lorentz's contraction theory a scientific fact. Regarding the Michelson-Morley experiment, he writes,
"There was just one alternative. The Earth's true velocity through space might happen to have been nil. This was ruled out by repeating the experiment 6 months later, since the Earth's motion could not be nil on both occasions. Thus, the contraction was demonstrated and its law of dependence on velocity verified."
Eddington's reference to 6 months later refers to when, in the heliocentric system, the Earth is moving on the other side of its orbit around the Sun. That is, Eddington makes his argument by first presuming the Earth is revolving around the Sun, which then leads him to the conclusion that Lorentz's contraction of matter was proven by Michelson's experiment. In common parlance, Eddington fell into the logical fallacy called begging the question. That is, using as proof the Earth revolving around the Sun, the very thing he is trying to prove, the Earth revolving around the Sun. The fact is, however, no contraction of matter was ever demonstrated, for no one had ever measured one. Like his contemporaries, Eddington depended solely on his unproven but foundational truth that the Earth was revolving around the Sun, and therefore, in his mind, there could be no doubt that a contraction of matter took place, since the only alternative was becoming a geocentrist.